Welcome to qnawire.
So here, essentially, we have an equation that the horizontal position and the vertical position. Now, we can say that delta y is equal to vy initial times t plus 1/2 gt squared. And then similarly, this is going to equal v initial sine of theta times t plus 1/2 gt squared. Now we can say delta x is going to be equal to the same vy x initial t plus 1/2 gt squared, rather the acceleration in the x direction t squared. But now here, acceleration in the x direction is going to be 0, so this term can be eliminated, and this is simply equaling v initial cosine of theta times t. So we can then divide these two equations and then manipulate solving for y. And we find that y is equaling tangent of the initial angle times x minus, and then this would be g over 2v initial squared cosine squared of the initial angle times x squared. Now, here we know that the initial angle is equaling 60.0 degrees. Y in this case would be 8.00 meters. And then we're solving when x is equaling 18.0 meters. So for part A, solving for v initial is going to be equal to the square root. And for the denominator, we have 2 times cosine squared of theta initial. This would be multiplied by x times tangent of theta initial minus y. This would, for the numerator, gx squared. After plugging these and g equaling 9.8 meters per second squared, after plugging in these variables for this equation here, we find that v initial for part A is 16.6 meters per second. This is how we would find the answer for part A. For part B, we can find the horizontal and the components. So we can essentially find the magnitude of the velocity of the ball just before it starts to build. We can say that Vx equals V initial x, and this would be V initial times cosine of theta. And we're using V initial from part A and then theta initial also from our given 60 degrees. So this is going to equal 8.3 meters per second, and that's how we would find the x component of the final velocity, because there isn't any acceleration in the x direction. So the initial velocity in the x direction would be equal to the final final velocity in the x direction. Vy final squared would be equal to v initial squared plus 2 times the acceleration in the y direction times delta y. Here we're going to use that upwards as positive, so acceleration in the y direction would equal 9.80 meters per second squared. And we can say that then the initial would be equal to negative the square root of v initial, which we have found 16.6 meters per second, multiplied by sine of 60 degrees. This entire term would be squared plus 2 times negative 9.80 meters per second squared multiplied by 8.00 meters. And we find that Vy final is essentially equaling negative 7.1 meters per second. So we can find the magnitude. This would be equal to the square root of the sum of the squares. And this is going to be equal to 8.3 squared plus negative 7.1 squared. This is equaling 10.9 meters per second. This would be our magnitude of the final velocity as it strikes the building. This is one answer. And then essentially theta would be equal to arctan of the y component divided by the x component. This is equaling 40.5 degrees. Now we need to know that the x component is positive, the y component is negative. So essentially, this is going to be in the fourth quadrant. So this would be 40.5 degrees below the positive x-axis. And so this would be our direction of the final velocity as it hits the building. That is the end of the solution. Thank you for watching.